Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience education. So today I am going to discuss about the chapter wave. Wave is a propagation of energy. Wave is a propagation of energy. Let us consider there is a wave like this. It means that there is an amount of energy which will propagate to the forward direction. It will propagate in this direction. Okay, so there is an energy transformation. So wave is of two type. One is your transverse wave, another is a longitudinal wave. In transverse wave, the wave is moving in such a way that the movement of the wave is in this direction, then but the particle will move up and down, that is perpendicular to this. See here, in the transverse wave, particle is moving up and down everywhere, but the wave is moving in this direction. So the angle between the movement of the particle as well as the movement of the wave are 90 degree. Now we can call about longitudinal wave. So what is a longitudinal wave? So it is a wave in which the direction of movement of the particle. See here, there is a compression as well as a rarefaction. So the particle is moving here to and fro like this, as well as the wave is moving in this direction. So the particle movement as well as the wave movement both have a same direction. So that's the criteria for the longitudinal wave. So the example of longitudinal wave is a sound wave, and the example of a transverse wave are light wave. So wave, if you want to define the wave, it is a disturbance that propagates in a space, transfer energy and momentum from one point to another without transport of matter. So finally it transports the energy without transporting the matter. If you take the example, see here in figure, see the energy is going constantly in forward direction, but the particle will remain at the same position. Here also you can see this is the particle. So particle is moving here and there, but the energy is being propagated for the longer distance. So in this way you can understand from this figure. Now what are the characteristics of the wave? When a wave passes through a medium, particle medium vibrates about their mean position and they do not leave their position and move with the disturbance. Okay, so these are the characteristics of wave. So particle won't leave its own position, but it will always move here and there about their mean position like this. See here, particle is not moving in this direction for long distance. It is just moving here and there in form of SHM. Here also we can see that the particle is moving. The particle is moving here, and you can see from here, particle is moving here and there in the form of SHM. Next is in a wave, motion of the phase of the particle during their vibration is different at a different position. The in a wave, motion of phase of the particle during their vibration is different at a different position. What do you mean by this? See here. At different position, see, at different position, the motion of the particle is different. See, if we talk about the particle like this, like this, like this, see here, you can see that the particle is moving here and there. Okay, so if in a wave, motion of the phase of the particle during their vibration is different at a different position. Next is the velocity of the particle during the vibration is different at a different position. So the velocity of the particle during the vibration is different at a different position. So when we talk about the different position, it means see here at this position, see here at this position, velocity of wave is moving like this. I can explain you with the diagram. Let us consider this is a wave like this, like this, like this. So the particle will move for at this point. Particle will move for this distance. At this point, the particle will move for this distance. At this point, particle will move for this surrounding. See here, the movement of particle depends upon its position. Okay, so this is the third characteristics of the wave. Now the fourth is the velocity of the wave motion through a particular medium is constant. So velocity of the wave motion. through a particular medium is constant. So if wave is moving in forward direction, if wave is moving in forward direction, see here, wave will remain constant. Wave will remain constant for particular medium. For particular medium. I hope you have understood now. Next is energy is propagated along with the wave motion. Yeah, if there is a wave is moving like this. So the particle movement is up and down, but the wave is moving in this direction. So the energy will also propagate in this direction only. Okay. Now for a wave propagation, medium should have a following property. First is elasticity, inertia, minimum friction among the particle, medium and uniform density. Elasticity. Medium should have the following property. Elasticity means what? It should be flexible. Inertia. Inertia means what? You know that inertia is means, let us consider SHM. See here, if this bob, if we put some energy, so it will go in this direction. So after certain period, it will come at this direction. Okay. Next is minimum friction among the particle of a medium. So there is a minimum friction required from the particle in the medium. See here, if bob is moving, so it should get the least friction so that it can move up and down. So the air should apply a less amount of friction to this bob, and uniform density. So that if you talk about the air, so air will have least density. Okay. Now types of wave. So the wave on the basis of the necessity of the medium, mechanical wave, they are required for medium for the propagation, wave on a string, wave on a water surface. So mechanical wave, they require a medium for propagation. So the wave which required medium for the propagation is called mechanical wave. Okay. For example, water sound wave required medium for propagation, so that's why sound wave is known as mechanical wave. Water movement, see at the surface of water you will able to see the wave. So this wave is required a medium for the movement, so this is also known as mechanical wave. Non-mechanical wave, they do not require a medium for their propagation. Example, light. So you know that light is a electromagnetic wave. It is not dependent on the medium. So let us consider this is electric field, so it will create a magnetic field B here. After that is it will create a electric field, and this electric field will again create a magnetic field. This magnetic field again create a electric field, and this electric field again create a magnetic field. In this way, so the wave will move without taking any help. So example is light wave, heat wave, infrared, x-rays, all does not require any medium for the propagation. So this is known as non-mechanical wave. Now on the basis of the vibration of the particle, transverse wave. In the transverse wave, the particle medium vibrates in a direction perpendicular to the direction of the wave. So just now we have discussed. Let us consider there is a wave is moving like this. So see here, the movement of a wave is in this direction, but the particle is moving top and bottom like this. So what is happening here? The movement of particle and the velocity of the wave both have 90-degree angle. Now longitudinal wave. In this wave, the particle of the medium vibrate in the direction of the wave motion. Okay. In longitudinal wave, in their wave, the particle of the medium vibrate in the direction of the wave motion. It travels in the form of compressor and rarefaction wave. See here, compression and rarefaction means what here? Let us see. This is a compression. This is a rarefaction. This is again a compression. This is rarefaction. So what is happening actually? This particle is moving in as form of SHM like this and this. The wave is also moving like this. So this type of wave is known as longitudinal wave. Next is a wave equation. So let us consider wave. Wave is always move like this, like this, like this. When we consider this type of wave, so can we say that it is a sine function? So the sine function starts with like this, like this, like this, like this. So can we write the function y is equal to a sine omega t minus kx plus here a is the amplitude, a is your amplitude, a is amplitude, okay, omega t minus plus pi. As we have already discussed in SHM, what happened in SHM, we need to find equation of any type of SHM, you know that the equation is A sine omega t plus phi. But here we need to add an extra minus kx, and this is also known as angular wave number, and the value of k is equal to 2 pi by lambda, where lambda is the wavelength of the wave. So let us consider this is the wavelength of the wave. So the angular wave number k is equal to 2 pi divided by lambda. I hope you have understood now. Now every particle does SHM, okay, and all have a amplitude a, and the particle moves like this top and bottom, and the wave moves like this. So I hope you all have understood this. Since here y is equal to a sine omega t minus kx plus phi, now at x is equal to 0, what is the value of y? So if we talk about x is equal to 0, what is the value of y? So this is the x is equal to 0. So y has a value of a sine omega t plus phi, because if you put here 0, so it will become 0. Now at x is equal to 1, so y is equal to a sine omega t minus k plus phi. Okay, and this is known as initial phase. It is known as initial phase. So the phase we are talking about is the initial phase. Okay, so the initial phase is equal to minus k plus 5. Combining both them, then we will get the initial phase. Initial phase. Okay. Now see here. From here we can see that y is equal to a sine omega t minus kx plus 5. And let us consider two values of x1 and x2 are in a phase. Now, if x1 and x2, let us consider for x1 the phase is how much? Phase is equal to minus omega t plus omega t minus kx1 plus phi. And for the final phase, that is phi 2 for this x2 position is how much? Omega t minus k x2 plus phi. So the phase difference is equal to phi 2 minus phi 1, and if you put the value, so we will get k into delta x, and this is known as phase difference. So if there is a particle moving in x1 and there is another particle at x2, so the phase difference will be how much? Phase difference will be equal to k into del x. So phase difference delta x is equal to k into delta x, where delta x is a change in change in position. Okay, now since phase difference is k delta x, and we know that 2 pi is equal to k into lambda, so finally k is equal to 2 pi by divided by lambda. If we put up, okay, so this relation we should memorize so that we will able to solve some of the questions. So let us try one question. Here it is given that two sound waves having a phase difference of 60 degree. So that delta phi is how much? 60 degree. Okay, 60 degree, can we convert it into the radian? So it is 60 pi 360 into pi. So this will be pi by 6. So we have got the phase difference. Have a path difference. Path difference means what? Del x, del y. We know that delta phi is equal to, just we have studied delta phi is equal to k delta x. K delta x. Okay. Also, one more important thing is equal to k is equal to 2 pi by lambda. is equal to 2 pi by lambda, we can put here 2 pi by lambda, and the phase difference we are getting is pi by 6. So here what we are getting, so we will get pi got cancel out, so into delta x. So from here delta x will be equal to lambda by it's pi got cancelled, so lambda uh, by lambda by pi by 6, the pi by 6. Here we have written that it will be I think if we convert it into, if we convert it into radian, so what we will get, it will be 60 by 360 into 2 pi, finally 2 pi by 6. So in place of this, what we need to do, uh, let us write here phase difference del phi is equal to J into path difference del x. We want del x. So in phase difference, we have got 2 pi by 6, and k is equal to 2 pi by lambda into delta x. From here, delta x is equal to lambda by 6. Hope you have understood now. So this is the question. So we will discuss more in the second part. Thank you.